Good day, everybody. We're going to start by reviewing some of the speed, velocity, and distance problems we did the other day. And since many of you were missing on Friday and we had the snow day yesterday, today we're going to begin by going over some of those speed and velocity problems. So everybody should have a worksheet in front of them that says speed, velocity, distance. That looks like the one that's showing up on this page. Go ahead and take a minute to put your name on it. And then what we're going to do is work these together as we did before. I'm going to go through and tell you the things you need to look for, to make sure you're watching carefully for. And then we'll work these through together. And after that, you'll have some problems to work on your own. So we're going to look at the main components of speed, velocity, and distance. So remember that in order to calculate speed or velocity, you need distance divided by time. So our formula for speed is a measure of motion equals the distance divided by time, or V equals D over T. And we normally measure that in meters per second unless we're told to do otherwise in the problem. Velocity is the same formula. The only difference is that we also give along with the speed, which is the rate at which an object changes its position, but we also give a direction for it. Okay, so if they're asking for velocity, make sure that you include a direction. So we're going to put plus direction. And you might want to do that yourself. And also, you're going to kind of have to put up with my very ugly and slow writing on here, because it's not easy to do. Might be able, hopefully you guys can do better. I might be able to do better with cursive. But anyway, you can read that. It says direction. Okay, in this case we're down here, and we're going to start by reading the thing, and we're going to circle as we go through here what they're looking for. So that will help you decide how to use your formulas. If you remember, we sometimes have to change our formula, and I'll put this up here, and that's my triangle that looks really bad, but it's a triangle with a capital T in it, and we know we're doing distance. I'm sorry, let me get rid of that. It's velocity. Velocity, or speed, equals distance over time. Okay, so hopefully my writing will get better as we go along here, because it's pretty bad right now. Okay, so let's look at the first problem. It says, it took Lightning McGreen 2.5 hours to travel 600 kilometers. How fast was he going in kilometers per hour? So we see that we're looking for how fast. So how fast is speed, right? So we're using our V equals D over T. Always write your formula in. So you guys write yours in on your paper. V equals D over T. And it doesn't matter if you write it slash like this or over top like that. Either way is fine. Then you write your equal sign. And then you do your 600 kilometers is our distance, and they told us that we don't have to do any changing. They want it kilometers per hour, and that's what we have, kilometers per hour. So our distance is 600. That's bad writing. Kilometers. And remember, every number you write down must have an SI unit next to it. And then, what's our time? 2.5 hours. And make sure your decimal point shows. Okay, make sure the decimal point shows. And then grab your calculator and quickly put that in the calculator. If you need to hit pause right now, you may do that. And write your answer in. Okay, let's look at this one. You should have written your answer in over here now. This one says, it took Miss Raleigh 4 hours to travel 165 kilometers due north. What was the velocity of her car in kilometers per hour? So the first thing you say to yourself was, what are we looking for? And it's velocity. So we're using V equals d over t again. Except that now they really are asking for velocity, so that means we need a direction in our answer. Remember that velocity is the rate at which an object changes its position plus its direction. So we know that if we go up here and look, we actually see a direction. It's right here, north. Okay, so we're going to write our equal sign. Our distance is, let's see, it took her 4 hours to travel 165 kilometers. So it's 165 kilometers. And our time is 4 hours. So you write 4 hours. And you can at this time pause and go ahead and do your calculation. Don't forget that your final calculation should be in kilometers per hour. The same with this one, your final answer with kilometers per hour. You'll lose points on your tests and quizzes if you don't put the SI units next to every number. Go ahead and pause and write your answer down. Okay, well now we're on what is the speed if distance is 340 kilometers and the time was 3 hours. Was Jader speeding? So if we look at this, we have a speed limit of 80 kilometers per hour. That's information we need for this last part. So we are looking for speed, and so we're using V equals D over T. I know that doesn't very much look like an equal sign, so I'll erase that out of there. And we're going to set our numbers up. We have a distance of 340 kilometers. And we have a time of 3 hours. That doesn't really look like a 3 very well, but it is. Time of 3 hours. Okay, you're going to go ahead and do your division, and you'll get your answer. And then that will take care of the first one. So if this distance is 340 kilometers and the time is 3 hours, this, when you do the division, will give your answer of his speed. But then the second part of the answer was Jader speeding? So whatever this answer turns out to be, if he's over 80 kilometers per hour, then yes, he's speeding. If he's under 80 kilometers per hour, then no, he's not speeding. So your answer should say, yes, he was speeding because he's over 80 kilometers an hour, or no, he was not speeding because he's under 80 kilometers an hour. So make sure you put that in there. Don't just write yes or no. This is science. You always have to back your claim up with some data. Go ahead and hit pause and finish that. Hey, you should be back for this question. How far did Doc Budson travel if he was going 60 kilometers an hour for 4 straight hours? So now, how far? So when we go back and look at the parts of our formula, velocity or speed, distance, and time, we are now looking for distance. So distance equals V times T. When they're next to each other, you multiply. When they're over each other, you divide. So we're looking for D. We're looking for that, and they're going to give us speed and time. So we're going to multiply that. So we go down here and write it like that. D equals V times T. You could put them in parentheses if you want, or you could just put them next to each other this way. And so our written out one will look like 60 kilometers. And he did km per hour. You know what, I'm going to erase this for a second and write it below so we have more, I have more room. I know it's hard to read this way. So I'm going to go down here and write it. I'm just writing it below here because I don't have enough room. So we have, he's traveling 60 kilometers an hour. And we multiply that times the time, which is 4 hours. So you could take a second and multiply that out, and because hours here will cancel hours here, you'll only be left with kilometers, and kilometers is a distance, right? So when you multiply these out, that answer will be written with just kilometers afterwards, and that'll be your distance. Go ahead and pause and finish that. This last one is, what is the speed if a runner runs a distance of 400 meters in 43 seconds? Okay, so now we're back to the real, like most scientific velocity problems are done in meters per second. And so that's what we're going to leave it in, meters per second, and we're looking for speed. Okay, so speed is V equals d over t. Remember, the speed and the velocity are the same formula. The only difference is that if we had a velocity problem, we'd have to have a direction. This is a speed problem, so we don't need direction. Our distance is 400 meters. And we are going to put that over 43 seconds. Remember, seconds is just an S. Meters is just a lowercase m. So then in your calculator, you're going to put 400 divided by 43, and then you'll get your answer here and make sure it's in meters per second. Go ahead and hit pause. Finish up problem. Okay, you should be back for the last one. Okay, so what I want you to do on this last one is I want you to make a word problem here and have a peer solve it. Okay, so it's all fine and dandy to do your basic V equals D problem, meaning you're asking them to look for a velocity or a speed. Remember, if you ask them for a velocity, make sure in your word problem you include a direction. But it's also possible in your word problem you ask them to look for D equals V times T. That means you're asking them for a distance, so make sure that you give them a speed and a time. Or you can ask them to do a time. And if they're doing a time, then they are going, if you go back up to our problem up here, if they're doing time, then the formula will be D divided by V. So T equals D divided by T. Okay, so make up a word problem. Go ahead and write it on your thing, and then your partner can solve the word problem down here, and then you make sure you know your answer for your word problem, then you switch your papers back and grade it. So go ahead and do that now, and then make sure as soon as you have that finished, you turn it into your teacher and get the 5 word problems you're going to work on for practice on your own without me walking you through it.